Welcome back to Integral Calculus. In this video, we're going to be using what we have already learned about partial fraction decomposition to integrate rationals. So here is the rational integral I'm going to be looking at. Integral of x cubed minus x squared plus 2x plus 3 all over x squared plus 3x plus 2. And if you think back to what we talked about when we were using partial fraction decomposition, you should immediately notice the problem. The degree of the numerator is bigger than the degree of the denominator. So our one tool for simplifying a rational and making life easier on ourselves is right out the window. So you have to cast your mind back to another tool that you have learned about at some point in the past. This one I'm a lot more confident that you've seen before, which is why I didn't want to spend an entire video reviewing it. This one is polynomial long division. I want to take x squared plus 3x plus 2 and divide it into x cubed minus x squared plus 2x plus 3. Whenever I remind students of polynomial long division, or even if I'm just introducing it for the first time, I like to remind you that it works very similarly to long division for integers. 132 goes into 1,423. Well, 132 goes into 142 one time. 1 times 132 is 132. Subtract that off, you get 10. Drop down the next number, which is 3. 132 does not fit into 103. That will fit 0 times. Subtract that off, you get 103. And we'll write that as our remainder. Polynomial long division works much the same way. We're going to focus on the lead term here, x squared. X squared times x is x cubed. I've got 3 terms out here, so I go in 3 places and write in my x. Very conveniently doing that has my x lined up with my other x. Multiply x times the thing in front. X cubed plus 3x squared plus 2x. And here's the challenge of this. I need to subtract all of this stuff. It is very easy to make a sign, S-I-G-N error, when you're going through this process. X cubed minus x cubed is 0x cubed. The lead terms cancel out and become 0. If that doesn't happen, something has gone wrong. You've made a mistake. Minus x squared minus 3x squared, all told, is minus 4x squared. 2x minus 2x is 0x, and yes, I am going to write down the 0x. It will be a nice placeholder. It will make my life easier. Drop down the next term, which is plus 3. Now repeat. X squared times minus 4 will give me minus 4x squared. And when I multiply, I get minus 4x squared minus 12x minus 8. And then I have to subtract that. Minus 4x squared minus 4x squared is 0x squared. The lead terms are 0. If that doesn't happen, something has gone wrong. 0x minus negative 12x is positive 12x. And 3 minus negative 8 is positive 11. That's my remainder. I write that as the numerator of the fraction, and then the denominator of the fraction stays the same. And so with that, I can rewrite my integral. Instead of calling it the integral of x cubed minus x squared plus 2x plus 3 all over x squared plus 3x plus 2, it is going to be the integral of x minus 4 plus 12x plus 11 over x squared plus 3x plus 2. And then I'm going to split it up. The integral of x minus 4 is easy. The integral of 12x plus 11 over x squared plus 3x plus 2 is, well, harder. I'll stare at the fraction for a few moments, see if I can see an obvious substitution or something to that effect that will make my life easier. I don't in this case. So I'm going to proceed to partial fraction decomposition. X squared plus 3x plus 2. That factors pretty nicely into x plus 1 times x plus 2, which means that this is going to decompose into some constant over x plus 1 plus, make sure that looks like an x and not an a, plus some other constant over x plus 2. Multiply through by the common denominators. And then from there, set up a system. This one's not too bad. 12 equals a plus b. 11 equals 2a plus b. So it looks like if I subtract these, I'm going to get 1 equals negative a, which means that a is negative 1. And I guess the only way that works is if b is 13. Very ironic for me, b is 13 when my b's and my 13s very often look the same. All right. So I need to copy everything down. That first integral stays the same. Nothing is going to change there. That second integral is going to be that wasn't supposed to happen. What did just happen? All right. There we go. Now that I've got everything working with me again, and I can plug in the values of a and b, and each of these integrals on its own is pretty straightforward. The integral of x minus 4 is 1/2 x squared minus 4x. The integral of 1 over x plus 1 is the natural log of the absolute value of x plus 1. And the integral of 1 over x plus 2 is the natural log of the absolute value of x plus 2. You could combine those natural logs if you really want to. I don't think it's valuable to do so. So I'm just going to leave it like that. All right. I think it's fair to say that this process is annoying more than it is difficult. Certainly we could end up with messier things going on, but the basic idea is going to be the same. Instead of dragging this video on, let's just wrap up with one for you to try. How about the integral of x cubed plus 2 over x squared plus 4? All right, take a couple of minutes, see what you can do with that one, and I will see you in the next video.